All right, good morning. Welcome back to Elements of Calc 2. So today we're going to continue talking about some definite integrals, and I've got a class of integrations that if you're actually taking the class from me, you will definitely see on exams because I tend to like these problems. So let me show you what's going on with this and how to deal with them. I'm going to put them in the context of dealing with a definite integral, but they don't have to be definite integrals. They can be indefinite integrals. The technique for doing this is exactly the same. But let's start off with one that's real easy. We'll just start off with the square root of 2t plus 5 dt. We're going from 0 to 5. Okay, so that's not too bad. We're just going to say, oh, let u. Okay, and then again, notice the integration variable we're integrating is going to be t. We have a dt for that variable. So we're going to say let u 2t plus 5. Again, always in calculus, when you make a substitution, the first thing you do is take its derivative to make sure that the scaling is correct. And then we're going to go ahead and make a substitution. dt is equal to du 2. Okay, just solving for dt here. Now, the next thing we're going to do, because we could go ahead and integrate this and then go all the way back to our t values, okay, but one thing that you might want to deal with, instead of going all the way back to t, is to go ahead and say, well, once I've integrated with u, why don't we just do that? So we're going to say when t equals 0, u equals 2 times 0 plus 5. 2 times 0 is 0 plus 5, we end up with 5. When t equals 5, u equals 2 times 5 plus 5. So we end up with 2 times 5 is 10, plus 5 is equal to 15. So what's going to happen here is we're going to go from 5 to 15. Okay, so we're changing our limits of integration. So now we're in the t world rather than rather in the u world rather than in the t world. Okay, so if you ever hear other YouTube creators do that, other mathematicians do that, that's what they're talking about. We change from the limits of integration that were given for t, we change them to the limits of integration for u. It's very common, and it does help save us a step at the end just to make sure that we're going to be okay. This 2t plus 5, that was now by u, so we're going to go ahead and say this is u to the 1/2 power. Okay, so that's what's going to be in here. And then this dt, this is going to be du over 2. So I'm going to go ahead and move this 1/2 out in front. So we have 1/2 integral from 5 to 15, u to the 1/2 power du. And then just like every integral that we have, we're going to just go ahead and apply our power rule to this. Every integral, but at least for these integrals, we're going to go ahead and apply our power. So we have 1/2 u. So I'm going to go ahead and add 1. But this 1 is going to look like 2 over 2. So that's what's written here is a 2 over 2. So we have 1 plus 2 is 3 over 2. And then we have to divide by that 3 over 2. And we are going to go from 5 to 15. Right? So we go ahead and we say we have to clean this up a little bit because you would leave it like this. 2/3, 2/3. So this stuff all cancels. That's the whole point. This 1/2 and this 2 up here cancel out. So we end up with a 1/3 u to the 3/2 from 5 to 15. Okay, now here's where it's going to get a little tricky. So your algebra is not quite up to it. We'll go slow so you can see what's happening. But as you do more of these, you'll sense a pattern. Okay, so this is going to be 1/3, and this u to the 3/2, this is 15 to the 3/2 minus 5 to the 3/2. Okay, so let's go real careful with this. 3/2 is really 2/2 times 1/2, or 2/2 plus 1/2. So this is going to be, let's parentheses down, 1/3. This 15, this is going to be the square root of 15 raised to the 3rd power. That's what this means. Okay, so this is going to be the square root of 15 squared times the square root of 15. 2 plus 1 would be 3. So the square root of 15 squared, that's just going to be 15 times the square root of 15. and then minus, and then here's where the magic happens. 5 square roots of 5. And unfortunately, there's not a whole lot you can do with this. I mean, I guess we could factor out a 5 or something and make this a little bit nicer, but there really isn't a lot we could do for here. Let's go ahead and do that 5 out. So we could say this is 5/3. If I pull a 5 out of here, then we're going to have 3 root 15 minus root 5. And there's really not much else we could do with this. There's not really a whole lot. There's some stuff we really wanted to force the issue. We could, but I think that my math lab is going to take this as an answer. It's going to be happy with this. Might even be happy with this piece up here. So this might be you're done. Okay, you don't have to go ahead and factor out these 5s out here. But just for completeness sake, I went ahead. So that is a pretty tame example. We're going to go on to something that's a little bit more complicated. This will demonstrate another problem, another one of the properties of integers for us. And it's going to be changing our sign. And find where am I? This. No, not that one. Not that one. This is it. Okay, very good. So we have another column here. Sorry about that delay. So we're going to go from, again, 0. It looks like we're going from 0 to 5. They're not all 0 to 5. They just happen to be the problems that I picked. So we have x times the square root of 9 minus x dx. And at this point, you're looking at like, I can't put this x on the inside because this is a square root. This is not a square root. So this is going to be kind of tough to do this. If I really wanted to force the issue, we could say this is the square root of x squared times the square root of 9 minus x. So we would end up with the square root of 9x squared minus x cubed. There's nothing on the outside. So if I try to do a du or try to do something that's going on in here, I'm not going to have a lot left over to see what's going to happen on the side. So this u is not going to work so well. But again, when you've got this x term times some kind of a square root or 1 over a square root, something like that, this is, like I said, this is a type of integral that you're going to see, again, if you're taking the class from me. This is one of my favorite styles of doing this because this is the hard one. Okay, they're not all going to be problems like this, but this is how I tell. Did you do your homework? I ask you a problem like this. So you're going to definitely see one of these again. So I would say, let u equal 9 minus x. Well, if u is equal to 9 minus x, again, we're going to go ahead immediately, we're going to say du is equal to negative dx. Okay, and then the other thing we're going to do is we're going to say, well, if u is equal to 9 minus x, if I add x to both sides, we're going to say x plus u is equal to 9. Therefore, x equals 9 minus u. So we can substitute in for x as well as substituting in for u. We're going to do both of those substitutions. But first, we're going to change our limits. So we're going to say, what was u? U is equal to 9 minus x. So when x is equal to 0, okay, u is equal to 9 minus 0 equals 9. When x is equal to 5, because that's my upper limit for my integration here, we're going to have u is equal to 9 minus 5, which is equal to 4. So let's go ahead and clean this up and like deal with the integral that we actually have now. So we have the integral of, go that from 0, which in the u world is 9, okay, and then we go from x equals 5, but in the u world, that's 4, okay? And then we can go ahead and start substituting. What the heck was x? X was 9 minus u. We have the square root of 9 minus x, which is u. So we're just going to go ahead and write, actually, I'm not even going to write the square root. Just forgive me for that. Okay, we're just going to write this as u to the 1/2 power. Okay, and then we have our dx. What is dx? Dx up here is equal to So negative du would equal to dx, just for going from here. Okay, so we're going to say this is going to be negative d. Okay, let's clean this up a little bit. There's a negative sign. So we have a negative integral I4. I have got 9 minus u times u to the 1/2 du, that negative sign flipped outside. Do you remember that one of the ways we go ahead and deal with this negative is you could flip the signs for addition? That's exactly what we're going to do. We're going to say this is now going from 4 to 9. I don't have that negative sign anymore, but I do have 9 minus u times u to the 1/2. Well, this is just, we can just factor this in. Okay, we're not factoring, we're not foiling over arithmetic really. We don't have side of a square root or anything like that. We do, but it's hidden now. So we can say this is going to be 4 to 9 for 9 u to the 1/2 minus u to the, this is 1. We're not integrating yet. We just add the exponents. We have 2 halves plus 1 half. 3 halves. This is all times du. Now we are ready to have our limits changed. We have everything is in u. And even though these are ugly, that's the way that goes, but we are all ready to go with this. So we can go ahead and integrate. So we're just going to, now we're going to take our integration steps. So I'm going to add 1 on the top here. So I have 9u, 2 plus 1 is going to be to the 3 halves. On the bottom, I'm going to have 3 halves. And then minus, and then here I have u to the, again, we're going to add 1, 2 over 2. 3 plus 2 is 5 halves divided by 5 halves. Okay, and that 9 only went with the first term, and then we are here from 4 to 9. Okay, so let's go ahead and clean this up a little bit. I've got a 2/3 top and bottom here. So 9 divided by 3 is going to be 3. 2 times 3 is going to be 6. So I've got 6 u to the 3 halves minus 2/5, right? Because we're multiplying by reciprocals here, 2 over 5. 2/5 u to the 5 halves, going from 4 to 9. Okay, so now we just have to plug these things in. So I have 6 times 9 to the 3 halves minus 2/5 times 9 to the 5 halves, right? And that's going to say u evaluated at 9 minus, right? And I have 6 times 4 to the 3 halves minus 2/5 times 4 to the 5 halves. Okay, so that's u evaluated at 4. So we have a little bit of arithmetic to kind of deal with here. 9 to the 3 halves, but let's go ahead and we can do this in little pieces so we don't have to worry too much about what's going on here. We have 9 raised to the 3 halves, so 3 divided by 2, or 1.5, that'll still work. Okay. But the square root of 9 is 3, 3 cubed is going to be 27. Oh, look at that. So we have 6 times 27 minus, and then we have 2/5, so it's going to be very pretty. The 2/5 times have 9 rather, 9 raised to, and again, we're going to have 5 halves. So this is going to be to the 2.5. 2. How about 5? 9 to the 2.5. So again, we're going to say 9, the square root of 9 is 3. 3 to the 5th, I have no idea if it's like 243 or something. The calculator is going to do the heavy lifting for us on this thing. We're just going to go ahead and take this in. Look at that, 243. Okay, and this again is u, this is evaluated u is equal to subtract. We have 6, and then we're going to go ahead and we're just going to take this apart here. And I know this is going kind of slow. You are not going to go this slow when you start getting up to speed. This is going to go much faster for you. 5. So that's what 3 halves simplified. So that's going to be 8. So we have 6 times 8 here. Minus, and I have 2/5, and I have 4 raised to the 2.5 to the 5 halves. So we have 4 raised to the 2 times 32. Okay, is equal to. And again, I know I'm doing a lot of steps to kind of get this to come out right. This is the trickiest part of, like, you think like, oh, the calculus and like all these little tricky things that we do. Like, yeah, the arithmetic is where it gets you. Okay, that's the part we have to be a little careful on. This is the part that's if you're gonna make a mistake, this is it. So I just have my 6 times 27. This is my 162 minus, and now I have 2/5 times 243. So we'll just say this is 2 times 243, 240 equals, this is 486 over 5. Okay, and then we have minus 48. And again, this negative distributes to both of these. So it's going to be a minus 48. And then I've got 2/5 times 32. 2 times 32 is going to be 64 over 5. So I'm just going to go ahead and add up all of these things. Again, I know that you probably do this faster, and that's fine. We have 162, but I don't want to make this wrong. So we have 486 divided by 5 minus 48 plus 64 divided by 5. Fingers are crossed that we get an answer that looks reasonable. So we ended up with 29.6. That's fine. You can say this is 29.6. Anytime you have a decimal that ends in a 2, 4, or 5, 10, multiples of those, it'll be just fine to leave it as a decimal. Just going to go ahead and change it to a fraction. That is for aesthetically pleasing to me. 148 divided by 5. We're very welcome to leave this as 29.6. Okay, I just think the fractions are prettier. I changed the fractions. So let's do another one that's kind of like this. Okay, and again, the tricky part of this is realizing, like, I'm going to have a tough time with a u substitution here. So we did this, we found like there is no big u substitution, but there is. We just have to kick the tires a little bit here, and we solve it for x as well. That's very common, and even the when you get to take the calculus class for scientists and engineers, this is a lot more common. It's a lot more screwy backward substitutions and forward substitutions and everything else. So your problems are pretty much limited to things that look like this, okay? Things that look like this, rather. So you don't have the whole craziness of what's going on. But there still is some craziness, okay? So we have a little bit of what's going on here. A whole bunch of these types of things. Let's see if I can find another good one here. Not that one. That was it's pretty tame. That's the one. There it is. So I want the integral from 0 to 4. Okay, and we have x dx divided by, I have a square root of 4x plus 9. Okay, so again, these don't have to be definite integrals. These could be indefinite integrals too. But since we're on the indefinite integral chapter, I'm just going to go ahead and throw this in here. So it's going to get both of these things. So again, we have a denominator with a square root of 4x plus 9. That doesn't look that much fun. But I realize, like, hey, if my u is equal to, so we're going to say let u equal 4x plus 9. So we're going to say du equals 4 dx. Well, that doesn't solve all of my problems, because if I go ahead and say dx equals du over 4, and I go to back substitute, I'm still going to be sitting here with an x. Okay, let's go ahead and do that. So we have, we're not going to change the limits of integration yet. We have x, and what was my dx? It was du over 4 divided by, and I have the square root of u. Okay, so let's go ahead and move this out. So we have 0 to 4 got 1/4, and I have x du, and I'll say times u to the negative 1/2. That's what this under the square root bottom means, negative square root. Notice we have x's and u's in my integrand. It's the thing inside the integral sign. I can't integrate this yet. Okay. So later, much later in the class, we get to integrate two variables. For now, we can't do that. Okay. So because I have an x and a u, I'm still going to do something about this x. So what we're going to do is we're going to say, well, it said let u equal 4x plus 9. Let's go ahead and solve for x. So we're going to say u minus 9 equals 4x. X will be u minus 9 all divided by 4. I would just leave it that way because we're hoping something will happen that makes it so it's not quite as ugly. And let's go ahead and see what happens. So when I go back to my 0 to 4, what the heck was x? This is u minus 9, right? Times a quarter, times 1/4. Remember that there was a 1/4 out in front here? So we have a quarter out here times this, and we have our du. Okay. Now we can go ahead and move this 1/4 out in front, so we're going to end up with a 1/16, it's 4 times 4, and then I've got my integral u minus 9. I forgot about this u to the negative 1/2 power. Okay, there's still a times a u to the negative 1/2 here that I forgot about. So I'm sitting over here. Okay, from this point, instead of going from 0 to 4, why don't we go ahead and say when x equals 0, u is equal to 4 times 0 plus 9. 4 times 0 will be 0 plus 9 equals 9. When x equals 4, we have 4 times 4 plus 9. This is going to be 16 plus 9. That looks like 25. But those are nice numbers. Somebody wants to pick these out just special for us. Okay, so we end up with a 9 and a 25 here. Now we don't have to back substituting for x's. Once we're done integrating, we can just go ahead and substitute in our 25 because we're in the u world rather than in the x world. Okay, let's go ahead and factor or FOIL this out. So we have 1/16. We still haven't integrated yet, so we leave this chapter here. And then we have u to the 2/2. Remember, we just add the exponents. So this 2/2 minus 1/2 to the 1/2 minus u to the negative 1/2 du. Again, those have to work in tandem with each other. And now we're ready to integrate. So we have 1/16. Okay, and then we have u to the 3/2 divided by 3/2 minus 9 u to the negative 1 plus 1. Right? Negative 1/2 plus 2 is 1, right? Negative 1 plus 2 is going to be 1/2 divided by, okay? So remember this 1/16 is the whole thing here. You're going from 9 to 25, right? So there we are with that. So here we are with our 1/16. I have 2/3 u to the 3/2 minus 9 divided by 1/2 is going to be 18 u to the 1/2. Okay, and I think we are ready to start go ahead plugging in some values here because we have to go from 9 to 25, right? So we have 1/16 times 2/3, and if I just plug in the 25 here, we're going to have 25 raised to the 3/2 power. Remember, there's a trick that's going to happen here. It's going to be 25 times the square root of 25 minus 18, right, times, again, we're just plugging in 25 here. So 25 to the 1/2 power. Okay. 25 to the 1/2 power is something we can actually deal with. So we have 1/16. Okay. We have 2/3. And then here we have 25 times the square root of 25. Right? That's what the 3/2 power means. This is going to be kind of easy to figure out. Minus 18, what's the square root of 25? is 5. Okay, so we just evaluated it at 25. We still have to evaluate it at 9. So I'm just going to go ahead and leave a little note there. We still need to go u equals 9. Okay, so we still have some minuses to deal with. Let's go ahead and work through this. So the square root of 25 is 5. 5 times 25. We end up with 125 times 2/3 minus 90. This is all times 116. How delightful. Okay, and then again, we have to minus, and we haven't done this part yet. This is still u as a little. Okay, I'm just working this little part of it here. 125 times 2, that looks to be like 250 to me, divided by 3, minus 90. This is all times 116. Minus, actually, let me put this right here, so we have that. We're going to have, okay, we are going to have u evaluated at 9. So we're going to have 2/3, and then we have 9 to the 3/2 power. This is going all the way back up to here, minus 18 times 9 to the 1/2 power. Okay, so we'll go ahead and sort this out. So we've got 2/3, and then here I have times 9 square roots of 9. That's what 3/2 is. Minus, this was 18 times the square root of 9, which is a fancy way to say 3. So we'll go ahead and say that. So this is going to be 2/3 times this business here. So we have 2/3 times the square root of 9 is 3. So this is going to be 9 times 3, 27. Minus 18 times 3. I think that's 54. Okay. And then 2/3 of 27, we have to figure that out. That's going to be a 9, so we'll end up with 18 minus 54 here. This was you evaluated at 9. And then we have a minus here. And then we have 1/16 times everything, 250 over 3 minus 90 minus this difference here. Okay, so it's definitely time to use a calculator. You can certainly, you're welcome to go ahead and use the calculator earlier than what I did. I just kind of like to take it slow so people can see exactly what's happening. We have 250 divided by 3. And I'm sorry if that's confusing. Minus 90. Minus, then we have 18 minus here, but we have to use a parentheses, minus 54. Right? That end up with 29 and 1/3, 29.3. I'm going to go ahead and change this to a fraction. And we end up with 1/16 times, what did it say there? 88/3. That was this whole thing that came down to be 88/3. Does 88 go into 16? A little bit. Let's go ahead and try that out. So we 88 divided by 16 here. Okay. So let's see. We have 5.5. So not enough. So we'll go ahead and say we have 1 divided by 16 times, and we have 80 divided by 3. And we'll just go ahead and let that happen. And again, we're going to go ahead and change it back to its fractions. That's the easier way for me to think about this. And we end up with 11/6. Let's double check our calculator. Yeah, 11/6. So this was our answer, 1.8323. This would be our answer. This looks good. This is the kind of thing that you're going to be expected to be able to do. Again, you are certainly welcome to use the calculator more than I did. And the important part of this problem is this part way up at the top. The calculus is, that's the tricky part, but it doesn't get hard until we actually have to start dealing with some numbers. So this one is a little bit on the tricky side. So I use problems like this to separate my A's from my B's, my A's from my B's. So you definitely see at least one of these problems. The whole test is not going to be this problem. You definitely get some of the ones up here, okay, that we did first. But be on the lookout for problems like this. Do some of your homework. definitely has problems like this in it. So you can see like what happens when this goes on. I got to go ahead and solve for x, go backwards and forwards, substitute this way and that way. It all works out in the end. Again, the tedious part, plugging in the numbers and dealing with numbers. So I think 2 examples was probably good. This will certainly be some more, but we'll move on to the next topic. So thank you very much for watching the video, and see you